When historians recount the technological miracles that broke the back of the Axis powers in World War II, public imagination instantly drifts toward the atomic bomb, the B-29 superfortress, or the code-breaking machines at Bletchley Park. Yet, buried beneath those famous headlines lies a far more practical, everyday marvel that quietly dismantled enemy air power across both Europe and the Pacific. It was a bulky, olive-drab trailer mounting a 6-foot parabolic dish antenna, the SCR-584 Radar. Developed in absolute secrecy at the Massachusetts Institute of Technology Radiation Laboratory, the SCR-584 was not merely an incremental upgrade to existing detection systems. It was a quantum leap in automated fire control technology. Before its deployment, hitting a fast-moving high-altitude aircraft with anti-aircraft artillery was statistically equivalent to throwing rocks at birds in the dark. Standard anti-aircraft gunnery relied on human spotters, optical rangefinders, manual searchlights, and complex hand calculations to estimate where a plane would be by the time an artillery shell arrived. Against skilled enemy pilots conducting evasive maneuvers or flying through night skies and thick cloud cover, thousands of high-explosive shells were routinely expended just to bring down a single bomber. In the Pacific War, where Japanese aviators relied heavily on night raids, low-level torpedo runs, and eventual kamikaze tactics to bypass Allied naval screens, this reliance on human sight was a fatal vulnerability. The SCR-584 changed everything by taking the human eyeball and human reaction time entirely out of the tracking loop. To understand why the SCR-584 was such a terrifying tactical asset, one must look at the brutal mathematical reality of anti-aircraft warfare in the early 1940s. An aircraft traveling at 300 miles per hour covers nearly 150 yards every single second. By the time an optical observer spots the plane, aligns his sights, shouts coordinates to a plot room, and operators manually crank the elevation and azimuth of a 90mm cannon, the aircraft has already moved hundreds of yards away. Furthermore, anti-aircraft shells required precise mechanical fuse settings, so they would detonate at the exact altitude of the target rather than blowing up harmlessly above or below it. The early American SCR-268 radar had helped locate incoming formations, but its long wavelength signal produced massive interference, could not distinguish individual targets in a tight formation, and required a team of operators to manually adjust dials to track the signal's strength. The -584 Seychelles rupees solved every single one of these problems through microwave technology and conical scanning. Operating on a 10-centimeter wavelength powered by the revolutionary cavity magnetron, the -584 Seychelles rupees emitted a tight razor-sharp beam that could pin down a target with surgical precision. Even more remarkably, it featured an automatic tracking system. Once the radar locked onto an incoming aircraft, it stayed locked onto that aircraft automatically, motor driving its dish to track the targets. Every twist and turn without human intervention. When the SCR-584 was integrated with two other top-secret American innovations, Bell Labs' Mark IX analog electronic director and the proximity fuse-it created the world's first fully automated air defense kill chain. The radar continuously measured the target's exact distance, azimuth, and elevation, feeding this high-frequency stream of data into the analog director computer. The computer calculated the necessary lead angle, predicted the aircraft's future position, and automatically pointed for heavy 90 mm anti-aircraft guns using hydraulic servomotors. The human gun crews no longer had to aim, calculate, or track. Their sole job was to continuously load high-explosive shells into the breeches. To complete this deadly circuit, the shells were fitted with radio proximity Fuzzes radar transmitters inside the nose of the projectile that triggered detonation the instant the shell passed within 70 feet of an enemy airframe. The combination was catastrophic for enemy air forces. What used to require an average of 1,000 rounds of anti-ammunition to destroy one plane was suddenly accomplished with fewer than 100 rounds. The initial operational trials in the Mediterranean theater during early 1944 caught Luftwaffe aircrews completely off guard. But it was in the Pacific War against the Imperial Japanese Navy and Army Air Services that the SCR-584 reshaped the geopolitical landscape. As American forces initiated their relentless island-hopping campaign across the Central and South Pacific, establishing forward airfields and naval anchorages was crucial to sustaining momentum. However, Japanese commanders quickly realized that direct fleet engagements were becoming unviable due to growing American industrial superiority. Instead, Japan pivoted to persistent night raids, land-based bomber strikes, and specialized low-altitude torpedo attacks aimed at destroying Allied shipping and coastal staging grounds before operations could fully launch. In the humid, rain-soaked islands of the Solomons, the Marianas, and the Philippines, visual tracking was nearly impossible. Fog, torrential rainstorms, and pitch-black tropical nights shielded Japanese bombers as they conducted surprise strikes on critical airfields like Henderson Field on Guadalcanal, and later the vital staging harbors of Saipan and Leyte, until the arrival of the -584 Seychelles rupees. Japanese pilots operated with a high degree of impunity under cover of darkness, knowing that searchlights and manual anti-aircraft fire could rarely pinpoint a moving target in the pitch black. The arrival of this new radar system on the Pacific front was meticulously planned to coincide with major amphibious operations, ensuring that freshly captured airfields could be protected the instant heavy engineering units cleared the runways. American commanders understood that without adequate air defense, every airfield taken at immense human cost would simply become a bullet magnet for Japanese high-altitude bombers flying out of distant, heavily fortified bases. The SCR-584 was packaged inside an armored, all-weather trailer that could be towed by a standard military tractor or landed directly from the open jaws of a landing ship tank onto sandy shorelines. Within minutes of arriving at a staging site, the crew could raise the parabolic dish, calibrate the microwave generator, and connect the automated control cables to the nearest battery of heavy artillery. This rapid deployment capability meant that American invasion forces carried an invisible, impenetrable dome of radar protection with them wherever they landed, neutralizing Japanese counter-air operations before enemy tactical commanders even realized the radar had been brought ashore. The introduction of the -584 Seychelles rupees into the Pacific Theater marked the absolute end of Japanese nighttime aerial supremacy. Mobile trailer units were loaded onto tank landing ships and brought directly onto beachheads alongside invasion troops, often setting up operational perimeters within hours of the initial landing waves. Japanese aviators, accustomed to blinding ground crews with nighttime evasive maneuvers, suddenly found themselves targeted by anti-aircraft artillery that seemed possessed by an invisible, omniscient force. The SCR-584 did not care about pitch-black skies, heavy cloud decks, smoke screens, or rain squalls. Its microwave beams sliced straight through atmospheric disruption, picking up incoming flights dozens of miles out and automatically slinging heavy 90mm gun batteries directly onto the target long before the air crews could even hear the sound of artillery engines. Japanese pilots flying night missions reported frightening accounts of anti-aircraft shells bursting directly inside their flight formations on the very first volley, without a single searchlight ever illuminating their aircraft. The psychological toll was immediate and devastating. Strike missions that had previously achieved high survival rates transformed into suicidal gauntlets, where entire squadrons were wiped out before they could drop their payloads. As the war progressed into late 1944 and early 1945, the Japanese High Command grew increasingly desperate, recognizing that conventional air tactics could no longer penetrate the overlapping defensive rings of American warships and island bases. Japan unleashed its ultimate airborne weapon, the Kamikaze, or Divine Wind. Thousands of young, minimally trained pilots were placed in aircraft packed with explosives and ordered to crash directly into Allied aircraft carriers, transports, and radar picket ships. The sheer velocity, unpredictability, and suicidal determination of kamikaze attacks stunned Allied commanders. Traditional anti-aircraft doctrine fell apart against an enemy that did not take evasive action to survive, but instead deliberately dived straight into incoming fire to ensure destruction. On the naval picket lines surrounding Okinawa, shipboard anti-aircraft gunners were stretched to their absolute physical limits. To counter this existential threat, ground-based -584 Seychelles rupees units were deployed to key coastal positions, small outer islands, and converted landing craft, providing an impenetrable shield around vital anchorages and air bases. The SCR-584 proved to be the ultimate countermeasure to the kamikaze menace. Because the system was fully automated and possessed incredible angular resolution, it could track fast-moving, low-flying suicide aircraft through intense radar clutter caused by sea spray and land terrain. The system's lightning-fast processing meant that the moment a kamikaze emerged from cloud cover or popped above the horizon, the radar locked on. The analog computer calculated the intercept, and 90mm batteries opened fire with lethal accuracy. Coupled with radio proximity fuses, the shells did not even need to hit the incoming aircraft directly. Exploding nearby, the shrapnel shredded wing surfaces, detonated onboard aviation fuel, or sheared off control surfaces, causing the suicide plane to disintegrate into the sea miles before reaching its target. During the grueling Battle of Okinawa, where hundreds of kamikazes were launched in massive coordinated waves known as Kaikasui operations, SCR-584 batteries posted astonishing kill ratios, shooting down scores of incoming suicide aircraft, protecting critical staging areas that made the ultimate invasion of the Japanese mainland logistically feasible. The tactical dominance achieved by the SCR-584 extended far beyond simple anti-aircraft defense. It fundamentally altered how military commanders understood air domain control. Japanese military leaders had counted on the vastness of the Pacific, unpredictable weather patterns, and night operations to offset America's overwhelming industrial output. The SCR-584 stripped away every single one of these natural advantages by turning air defense into an automated, highly reliable engineering process rather than a game of skill and luck. The United States rendered Japanese air raids structurally obsolete. Japanese bombers could no longer hide in the clouds, strike under cover of darkness, or rely on massed low-altitude surprise runs. Every square mile of airspace protected by an -584 Seychelles rupees dish became a death zone for enemy aircraft. The technology was kept so tightly guarded during the war that Japanese military intelligence never fully grasped how American ground batteries were achieving such impossible accuracy, often suspecting some form of death ray or telepathic aiming system. Furthermore, the operational flexibility of the -584 Seychelles rupees opened up entirely new tactical applications that extended beyond defense and into direct offensive air control. In the closing months of the war, American forces began using the radar system to track friendly fighter bombers, guiding them through darkness and poor weather terrain. Precision ordnance down upon hidden Japanese supply caches and coastal artillery positions. By tracking both the ground target's map coordinates and the exact location of friendly aircraft in real time, radar operators could radio vectoring instructions directly to pilots, enabling blind bombing runs that caught entrenched garrison forces completely unaware. This seamless fusion of offensive air guidance and automated defensive shield capabilities solidified the -584 Seychelles rupees as the premier electronic combat architecture of the era. When the war finally ended in August 1945, the legacy of the SCR-584 was permanently cemented in the annals of military history. It represented the dawn of modern electronic warfare and automated combat systems, laying the direct technological groundwork for post-war missile defense radar, automated naval CIWS gun systems, and modern air traffic control networks. While heavy bombers and atomic weapons claimed the historical spotlight for ending the conflict, it was the silent, automated precision of the SCR-584 radar trailer that quietly neutralized Japan's offensive air capabilities, saved countless Allied lives on the battlefields of the Pacific, and forever changed the nature of warfare in the skies.